Alright, hey everyone, Chang here. This is the practice problem video series. For today's standard test question, we have this right here. Given f of x equals x minus 2 over 5, what is the inverse function? Now, the problem with this is this. We know functions, plain and simple. We know exactly what to do. We know how to solve it. Great. But every time we see like an inverse function, now we're a little hesitant. We're not entirely sure what it's asking. Here's the other thing. There's a common mistakes with function, in particular with inverse function, that needs to be addressed. A lot of people, when they see f to the negative 1 of x, they automatically assume, since this is very similar, or looks very similar, to an exponent, that this is the same as 1 over f of x. That's not the case. This is not true in any way, shape, or form. Okay, so make sure that we don't do that basic assumption. Now, the inverse function, even though it looks scary, it's nothing more than just another function. The only caveat is that an inverse function is usually in relation to a regular function. What it does is basically does the opposite. This one right here, for a regular function, we plug in a number, let's just say 1 for example, we just replace whatever x is inside that function with the number, in this case 1, and you get a result, right? That's your f of x, or f of 1. Now, what inverse function does is that in that, I guess you could say, end result, that outcome, if we grab that and we plug it back in, it'll give us what we originally put in. So in this case, we put in 1, it gives us some number, we grab that number, we put it in the inverse function, it's going to pop out 1, right? So that's what we're going to do. Given that we have this function, we need to find another function that does exactly the opposite of this. So that whatever number we put in, it gives us an outcome, we grab that outcome, we put it into the inverse function, it should give us back that original number. Now, there's a common way that we can go about to solve it. The f of x, a lot of people love substituting that for y. So rewriting the function as just y equals x minus 2 over 5. And I am sort of conflicted with this kind of way of approaching, because guess what? Yes, it's easy because we're so used to working with linear equations that just by substituting f of x with y, it makes this so much easier. Now, in order to find the inverse function, what I've seen in textbooks and I've seen shown in class is that first you write this, instead of f of x, you're going to write it with y. Then what you're going to do is you're going to switch the x and y. So the x and y, you're going to switch it around, and that means you get x equals y minus 2 over 5. And then afterwards, you solve for y. So you just start moving everything to one side so that you have y equals blah, blah, blah. So if we were to do that, well, let's just look at this. X equals y minus 2 over 5. So what you're going to do is you're going to multiply by 5 on both sides. This cancels. You basically have 5x equals y minus 2. You're going to add 2 on both sides, right here as well. And so you have 5x plus 2 equals y. Now, afterwards, the final thing that you have to do is remember that this, because we switch it, it's known as the inverse. So rather than have y, we're going to rewrite it not as f of x, but as the inverse function. So technically, this right here is going to be our f to the negative 1 power of x, or f to the negative 1, not power. All right, so let's see. Basically, the answer in this case is right here. Our inverse function is this guy right here, 5x plus 2. Now, this is a way to approach it, and I feel like I understand why they introduced it this way. Just working with x and y instead of f of x and then the inverse function is a lot easier, just, I guess you could say, from experience, right? Manipulating x and y is just a lot easier. So if you want to use this strategy, great. If not, then at least it's going to be very similar. Keep it as that and understand that you're solving for the inverse function, and then therefore go about a very similar notion of isolating what the inverse function is and then figuring out that in this case it's going to be 5 times x plus 2. Now, the last thing we got to do is actually we got to check it. And the best thing to do is, well, you can grab all of this guy, this inverse function, and put it in here and see it all cancel out. And in the end, the result should be x. Or you can grab this guy and put it into the actual placement of x for the inverse function, and they should all cancel out and give you x as well. So I'm going to erase all this, and I'm going to show you the plugging of both ways. All right, so I rewrote the inverse function right here, and what we're going to do is we're going to test to see if this is actually an inverse function of this. Now, once again, there's two ways. The first one is for f of x. Instead of x, I'm going to put the entire inverse function in there. So it's going to be f of the inverse function of x, like that, right? So when we look at this, 5 times, and instead of x, we're actually putting this whole thing in, which is going to be x minus 2 over 5 plus 2, right? These two are here. And then now we can start working out. The 5 cancels. We have basically, in this case, x minus 2 plus 2. These guys cancel, the minus and plus. And so we basically have x. Now, we can actually do the opposite. Like, we can flip it over. And we work with the inverse function first. And then inside the inverse function, we're going to plug in the original function. In this case, it's going to be f of x, right? And then we start looking at this. So instead of x, we're going to put 5x plus 2 in there. So it's going to be 5x plus 2 minus 2 all over 5. We see that these guys cancel right here, the plus 2 and minus 2. So technically we have 5x over 5. The 5 cancels as well, which gives us x. Now, since even though we flip it, right, notice that they all cancel each other out and give us x. X is our input. It shows that these two are basically inverse function of each other. This is a function, this is a function, they cancel each other out. Whatever this creates, this one undoes it. Whatever this creates, this one undoes it. So thank you for watching this video regarding this particular function and inverse function problem. See you in the next one.